All right, so when we talk about arithmetic sequences, and we're going to talk about two formats. All right, whole idea is to get a formula. So when we look at an arithmetic sequence, it's a sequence where the difference between each term and the preceding one is always constant. Now, if a sub n is a term, we're going to have some subscripts on here. Okay, we're going to have one term, we're going to call it a sub n. Preceding, and n is going to tell us the term number. Maybe it's the fifth term, okay? If I want to get the fourth term, then I'm going to go n minus 1. Isn't that the preceding term? Because 5 minus 1 is 4. And if I want the one that follows it, I'm going to go a to the n plus 1. Okay, n is going to be the variable depending on the term that we're talking about. Okay, so you're going to want to get used to this kind of format or variables. All right, there is always a constant, and we call it a d. That's what we're always adding to get to the next term. So it would make sense that one term minus the previous term is going to give me the difference. Okay, so for example, on the one that I wrote on the board, if I did 6 minus 3, I got 3. If I did 9 minus 6, I got 3. If I did 12 minus 9, I got 3. I always got the same d. All right, so when we talk about recursive, we're talking about if I want a specific term, I'm going to take the previous term and add my constant. That's what this is saying. So if I want the fifth term, I'm going to take the fourth term and add my constant to that. Well, that's fine. Recursive just means we're only finding the next term in the series. Okay? So if you want the next term, it's easy. But what's difficult is if I want the 80th term or the 100th term, well, dang, I got to go start at the beginning and add my d until I get to the 80th time that I'm doing this. So that can be very long and arduous. All right? So there's another one called the explicit form that we'll talk about in a second. But if this is my sequence, a sub 1 is 3, a sub 2 is 4.5. Now, I'm telling you it's arithmetic, so you've got to look for these keywords, because tomorrow we'll talk about geometric. And geometric means something else. But if it's arithmetic, we know immediately that we're adding. Okay? So if I'm telling you that this is an arithmetic sequence, what is my d going to be? What do I add to the 3 to get to the 4.5? Yeah, so my d, my common difference, is 1.5. All right, write the sequence as a recursive function. So I'm going back up to this formula right here. And I'm going to start with a sub n is equal to a sub n minus 1 plus d. Now, if I'm looking for a formula, then what I'm looking for is to keep it with my n's in place. All right, so a sub n is going to equal a sub n minus 1 plus 1.5. And so there's my recursive formula. Give the first 5 terms. Well, 3, 4.5. What's the next one? 6, then 7.5, then 9, and so those are the first 5. 1, 2, 3, 4, 5. So this is a sub 1, this is a sub 2, this is a sub 3, a sub 4, and this one's a sub 5. All right, so I want you to look at something up here. If I have 5 terms, how many differences are there? How many times am I adding a difference? How many? 4. How many? 4, right? So here is one difference, correct? Here is the next difference, and the next one, and then to get to my last one, there's so. Although I have 5 terms, I only have 4 spaces, which represent my differences. Okay, so when we look at the explicit formula, what's nice about this one is that if I want to find any term, 100th, 1,000th, all I need to know is what is the first term. And then we're always going to take n minus 1 because we don't have, if I want 100 terms, I'm only going to have 99 differences. I don't have 100. So that's why we get the n minus 1 times the difference, whatever that difference is constantly going to be. Okay? So you can find any term you want, but if you don't have the first term, then that involves some work. Oh no. Okay? You have to find it. So look at this example. Find the nth term for an arithmetic sequence with the first term at -5 and a common difference of 3. So if I'm telling you a common difference, it's automatically telling you that it's arithmetic. Tomorrow you'll hear a common ratio, but today it's a common difference. Okay? So this is the key word that's telling me it's arithmetic. So when you get a quiz or a test and I ask, you can't come up to me and say, well, is this arithmetic or geometric? I'll say, you got to look at the keywords. Okay. All right, so I know that a sub n is equal to a sub 1 plus n minus 1 d. Now remember, if I am trying to write my formula, then only things with n's are allowed to stay. Everything else needs to be substituted for. So let's see what we got. Do I know what a sub 1 is? What is a sub 1? Okay, I told you that the first term is -5, therefore a sub 1 is -5. Do I know what my n is? Nope. Okay, I don't know that. I don't know what my a sub n is, and that's fine because I'm trying to come up with my explicit formula. Do I know what my d is? It's 3. So it's plug and chug. A sub n is equal to 5 plus n minus 1 times 3. Now, yes, thank you. Okay, so we can't keep it like this. We need to simplify now. So what do I need to do to simplify? Add the 5. What? Carry the 3 throughout. So that means you're going to distribute? Okay. So yes, we distribute. So we're going to get -5 plus 3 and minus 3. Well, now we can combine our like terms, right? So a sub n is going to equal -8 plus 3n. Doesn't matter if you write it this way. I like to put my variable first. But that is your explicit formula. So if I wanted the 100th term, then I would go 300 minus 8, and I'd be done. It would be what the 100th term value is. Are we good? Oh, okay. All right, here we go. Next one. What is the 45th term for the arithmetic sequence? So we know we're adding, which means we're going to need a d, whose first 3 terms, so here's a sub 1, a sub 2, and a sub 3. And so we've got 5, 9, and 13. I want the 45th term. So I want a sub 45. That's what I'm looking for when I want the 45th term. So which of my formulas are going to allow me to? The recursive formula or the explicit formula? Explicit. It says a sub n is equal to a sub 1 plus n minus 1 d. Okay, so if I want a sub 45, I need to fill in all of that. I got to fill everything in. So do I know what a sub 1 is? Good. Do I know what my n is? Yep, it's the 45th term, so it's 45. Do I know what my d is? Yep, because I'm going up by 4s each time. And so again, it becomes a plug and chug. Okay, so I'm going to go, well, that equals 5 plus 45 minus 1 times 4. So 5 plus 44 times 4. 5 plus, is this 176? So what is a sub 45? What's the 45th term? 181. How are we doing? Are we okay? Okay, next problem. Find a recursive formula. Recursive. And an explicit. So I'm looking for two formulas. So the recursive is a sub n equals what? A sub n minus 1 plus d. (45 minus 1 is 44). Okay. So this is my recursive. My explicit says a sub n is equal to a sub 1 plus n minus 1d. All right. So in each of these cases, I need d. And I know that a sub 6 is 57. And a sub 10 is 93. And I'm missing a sub 7, a sub 8, a sub 9. All right. So I need to find d, among other things. But for my recursive right now, I just need d. How do I find that d? How am I going to use this information right here? So 93 minus 57 divided by the number of jumps. Well, how many jumps am I having? Well, I don't know. There's 6. I'm going from 6 to the 7th to the 8th to the 9th to the 10th. 5 terms, so therefore there are how many jumps? 4 jumps. All right, so what is 93 minus 57 divided by 4? 9. Therefore, my recursive one is easy. It is going to be a sub n is equal to a sub n minus 1 plus 9. All right. For my explicit one, though, somehow I'm going to have to figure out a sub 1. Somehow I need to figure out what my a sub 1 is. Anybody know how I can do that? Subtract what by 9? Okay, so that's wrong, because what happened, you're right, I can do that, because I only gave you the 6th term, so I can keep subtracting 9, right? Yeah, but if I give you a to the 100th, that would be a really long way to go about finding the first. Nancy? That would be 57 minus 9. If I do 57, then what is my n? If I'm using 57, then what is my n? It's the 6th term, right? So I'm going to go is equal to a sub 1 plus 6 minus 1, because I'm using my n. That's why I subtract the 1, and then times my d. Well, we just said that the d was 9, right? So 57 is equal to a sub 1 plus 45, yes? So a sub 1 is equal to 12, correct? Okay, so did I have to use 57? Could I use 93? And then what would my n have been? Exactly, okay? All right, so that means a sub n is equal to 12 plus n minus 1 times 9. Am I done? Am I done? Got to simplify it. So that's like you're substituting it in, but if you go back and look at the previous examples, I said let's work this out and simplify it in simplest format. So we distribute the 9, yes? And so a sub n is equal to 12 plus 9n minus 9. So a sub n is equal to 9n plus 3. That is my explicit formula. Are we good? So you might write yourself a little note. Make sure you simplify it here. Make sure you remember to distribute. That yes, this is right, but if you don't go this extra step and tell me what a sub n is, I will take off, because you haven't written it in slowest or simplest form. All so summation notation. I'm sure you guys have older brothers or sisters or cousins that are in the Greek life at their universities. All right. Ooh, nice look, Kellyanne. Yeah, you're like snarling. Okay. You know what? I went to Rolla, and had I gone to any other school, I wouldn't have joined this sorority. But sororities at Rolla were a place where at least you knew there were some girls. Because there weren't a whole lot. It was a 7-to-1 ratio when I went. So, what'd you say? Was that a good ratio? Yeah, it was good for me, but not for them. So. All right, so when I use this summation formula, it's telling me I want to add my terms. Okay, I'm trying to add my terms and come up with a value at the end. So this is saying I'm taking the sum from 1 to 6, the first term to the sixth term. So I'm going to add the first, the second, the third, the fourth, the fifth, the sixth, and I'll get a value. Okay? So, for example, if this is my explicit formula, and I want to figure out what the sum of the first 5 terms are, would you like to come in? There's seats in the back over here, or wherever you want. Okay. Then what I'm going to do is I'm going to figure out what these 5 terms are. So the first term is going to be -7, basically plus 3, correct? Because we're putting in 1 for n, so we're going to get -4. The second term is going to be -7, what? Plus 6, so I'm getting -1. All right, the third term, -7 plus 9, or 2. The fourth term is going to be -7 plus 12, or what? Okay, good. Now remember, this is arithmetic, so we're going up by what? 3s each time, so really 8 sub 5. Okay, that's easy. That's going to be 8. Okay, so if I want the summation of all of that, what am I doing with my -4, -1, 2, 5, and 8? Adding them together. Okay, so when I add them all together, what am I going to get? Yeah. So basically, it's just the value of 10. So this is the long way to do it. Summation from 1 to 5, from term 1 to 5 of n, of my explicit formula is 10. Okay? All right, but it's nice to be able to do partial sums. Okay? Right? Because a sub 1, a sub n, our subscript is our term. If it's n, that means we haven't specified what term we're talking about. So it's open-ended. Okay? All right, so partial sums. This involves finding the sum of a certain number of terms in a sequence when given one or more and or the common difference. So we're talking about arithmetic, and so we know we've got a common difference that's going to occur. So for each positive integer, the partial sum can be found by using the following formulas, and you will have to memorize these. So there's quite a few in this section that you're going to have to remember. Again, get those flashcards out and look over them every night. Okay? All right. So let's look. If I'm going from 1 to n of my formula, I'm going to take my n. Now, what is my n? Okay, but it's going to be whatever that value up on top is, correct? So if I'm looking from 1 to 100, I'm looking for the sum of 100 terms, n would be 100, correct? All right, so n over 2, and then this is the first term, and this is my last term. So this is a great formula to use when you know the first and the last. But if you don't, then you've got this other formula. Again, you need to know your first term, and in this case, what you need to know is your common difference. Okay, so this one is going to take, well, how many terms do I have times the first term? Because they're all going to have that first. It's just how many times are we adding our d to this, correct? All right, and then we're going to take our however many terms times n minus 1. We know n minus 1 because we're always going to have that many d's, right? So if I have 100 terms, I'm only going to have 99 d's. We talked about that, right? That's where this part comes. So it's n times a minus 1 plus n times n minus 1d over 2. All right, so let's look at this. Find the 12th partial sum of the arithmetic sequence. So I'm going from 1 to what? 12, because I'm finding the 12th partial sum. Okay, let's define what I know. What do I know in this problem? Okay, I know what is my first term. What else do I know? Okay, what is my D? It is 5, correct? I'm always going up by 5. I mean, I could be adding a negative value, so you don't have to think that you're always increasing. You could be decreasing. Okay? So it could be a negative value. All right, if I want 12 of them, which one would I want to use with this? Could I use the first one? But what would I need to find? The last term, okay? So if I'm going to find the last term, well, then I would use one of those formulas that I had before to find that 12th term. But that requires a little bit more work, whereas this one is just pretty much a plug and chug because I have all the information. So we're going to say, what is my n? Anybody know what my n is? Yeah. No, it's going to be 12 because where am I going? I'm going from the first term to the 12th term. That's my n. Okay? So I'm going to say my sum from 1 to 12 of a sub 12 is equal to n times a sub 1. Remember, write these formulas down to help you remember what they are. And then plug it in. My n is 12. My first term we said was negative 8. Again, I have 12 times 11. My common difference is what? 5 over 2. So most of you will be able to plug and chug this correctly, but it's how you put it into your calculator that you're going to have an issue. So get your calculators out, and let's see if we all can insert it into our calculator correctly. Does it matter if I put it on the top or the side? Where can it not go? Yeah. So I think you get 234 if you've done this right. Are we good? Player's going now. Okay, this next one is a little bit interesting. You really got to read this. What's making this question kind of different? It's the sum, multiples of, okay. Okay, so I want multiples of 3. Let's do an example. That means what's my first term in this sequence? What's my next one? What's the next one? Okay, so dot, dot, dot. What's my last term? So I know my first term is 3. My last term, I don't know what my n is here, is 333. What is my n? It's multiples of 3. 111, right? My first term is 3. I don't want 1 or 2. So there's my first one. So I'm going to take what my ending value is, right, to figure out my n, and I'm going to divide that by 3. Because I only have 111 terms if I'm taking every third one. So my n is 111. So, okay, so n to the 111th is 333. I want the sum of all of those terms. What formula should I use? Okay, what's my first one say? The sum from 1 to 111 of a to the 111th is equal to what? N over 2. So a sub 111. All right, so 111 over 2 times 3 plus 333. And what is that? $18,648. No, No. As long as you're putting this at the beginning and you keep writing your equal signs, then that's fine. I would have gotten the same answer had I used the second formula. Okay? Wouldn't have mattered. Is that the answer? 18,648. Right? Yeah. So 336 times 111 divided by the 2. No, that's not. Okay. All right, so then here's a real life problem. You kind of want to think about. This is why we've kind of come up, you know, when you're looking at salaries or companies are trying to figure out what's happening from year to year. Here's an example. You start out making a salary of $40,000 and you get a $2,000 increase every year. That's not even cost of living generally, but okay. How much will you earn in the first 10 years? So we are doing a sum from 1 to what? Of a sub 10. So n is equal to what? 10, right? I'm going from first, I'm looking for 10 years, so I'm looking for 10 terms. First, last, okay? What is this? A1. What is this? It's my D. Why do I know that this is arithmetic? Because I'm adding 2,000 every year, right? Okay, I'm not multiplying, I'm adding. So D is 2,000. So the sum from 1 to 10, the first 10 is going to be, which formula should I use? The second one, because I don't have my last year's salary, right? I just have the first year's. All right, so what's my formula? What is it? NA to the, Okay, all right, so plug it in. Fill in the missing pieces. And solve it. So yeah, that was principal. Like putting money into a bank, how much will we have at the end? Kind of the same idea, yeah. Last year. So you get about $500,000. $490,000 is what you should get. If you're really? It's like a backwards Z. All right, are we getting $490,000? Okay. All right, so if you look at your notes, you'll find that the next page on your notes starts giving you homework. You've got 19 questions. And I believe that you should have on the following page the answers, yes? So you should be able to come in with questions for me. Okay? All this homework should be on a separate page, yes.